Good morning. Now, welcome to the new session, and today we are going to learn in our data science and security a principle called as testing the models. So, whenever I want to deploy a model in our data science, we have to go for a rigorous testing process. So, what is meaning by testing the model and things like that I am going to talk in this video. So, what is meaning by testing? Very simple term, testing is giving a model a data which is unseen by the model. That means when I go for a examination system, I have to appear for a exam where the question paper is not known. That is my real testing. So, in a similar way, what we call as coming up with the perfect machine learning model is not as simple as you do not use a good testing methodology. So, if I want to test my model, I have to have a very sound and proof method of testing the model. This seemingly perfect model will fail the moment you deploy it. So, you can see here the model may fail. The reason may be either obvious or may not be obvious. Testing the model performance is not an easy task. However, it is an essential part of our every data science project. Without model testing, without deployment of the model and testing subsequently, your model will fail tomorrow or day after. So, which is not acceptable. Without proper testing, you cannot be sure whether your model will be working as per expected, and you cannot choose the best approach to solve the task in the mind or task in the hand. Now, if you see on the right hand side, I have shown you a caption here. I have a training data, I have a training process, and I have a machine learning model. Now, testing for different purposes. So, testing can be go for 1 mobile, 2 mobile, 3 mobile, or different people are testing my model. So, this is what we require. When we start testing our model, 3 things are very important. Number 1 is your test data. So, what is your test data? Do you want your model to be tested upon a seen data or a unseen data? Obviously, the answer is I have to test my model on a unseen data. However, when I want to train my model, the model has to be trained on a training data, and the training process has to be completely. So, for example, from our childhood, we will learn the alphabet. The training process starts from repeating the same thing again and again unless it gets cemented in the mind. So, the training process has to be completed by a model, and then when it is completed, we deploy as a machine learning model. Fine. So, this is what we do it, and if you see here, we have 2 ways of model testing. First is offline model testing, another is a online model testing. Now, let me describe about offline model testing, what is all about. So, offline model testing encompasses all the model evaluation process that are performed before the model is being actually deployed for. That means you are testing your model in the lab, in the laboratory where it is being developed, and then you perform all kinds of testing. Okay. So, before discussing online testing in detail, we must define the model error and the ways to calculate them. Now, whenever I am testing a model, definitely I am going to encounter some errors. What are those errors? How do you tackle those errors? These are all the points for a data scientist or a data engineer person or a data science personnel to deal about. So, we say that before discussing this, we must define our error, what kind of errors are tolerable, what kind of errors can be unresolvable, or what kind of errors are basically we can solve it. Okay. So, you can see a machine developer and commitment. So, I have a machine developer, I have a development commitment, and then I have 2 things, one is a test fail, another is a test pass. So, I run for a mock test. When I run for a mock test, definitely it has to run for a specified amount of time, and if the model is tested on a unseen data and it perform very well, then the model is accepted. Okay. So, this is one way of testing, and you can see the testing conditions I am going to vary each and every time when I run the model. So, this is how our model testing done on an offline basis. And when you go for a model testing, as I said just now, we have to worry about what is the model error or what kind of errors I am expecting from a model testing. So, let us try to understand model errors. So, whenever I am expecting a model to perform as per my wish, as per my desire, however, it is not possible. So when it is not possible, we encounter some kind of error. So can we see here, I have a x-axis and I have a y-axis. So and on x-axis, just to give a hypothetical example, I am having study hours in study time in hours. So 1, 2, 3, 4 up to 7, 8, and then what is my grade from 1 to, so I have a performance on green, on blue, on red. So what is my error? So if I study 2 hours, will I be able to have a succession on this line, on this line, or this line? So what we call, so when I have a grade point I want to achieve, I have a error. For example, this is what a line I am expecting to, but I am here only. So I have a error equal to 4 minus 2, error equal to 2. Similarly here I have an error. Okay, so I have error number 1, error number 2. How do I reduce the error? That means when I am performing a model testing, I am expecting a model to give a particular output, and when I am not able to get particular output, a different output than the desired one, we encounter a differential, and the differential is nothing but the error. Okay, so every model can make a mistake because collecting data, the model itself introduces implications about the nature of a problem. So I am collecting a data, for example, marketing people will not like to give the age, people will not like to give the model mobile number, people will not like to give the salary detail, but this is not a error. This is just a estimation. So you can have a model error also. The best example working a model is your brain. So that is what we always look for. So use a modeling in real time. The brain renders everything to see by interpreting electromagnetic impulses recorded by our eyes. While this picture is a world imperfect, it is useful to receive a 90% of the information. So even if my model is able to perform 95 or 90 to 95% as a correct one, I will accept that model as a working model. Thus, each model M tries to predict a real value y, but by making a guess is equal to y hat. So this symbol is called as y hat. So my actual output is y and my imagined guess output is y hat. So differential between the two y, 2 on the vertical axis, is what we call as an error. So this is how we define the error. So difference between the real value and the model approximation make up the model error. So I have a very simple formula, error equal to y minus y hat. So for regression problem, we can measure the error in quantities that model predict. For example, if a house price using a machine learning model gets a prediction of dollar, okay, 3 lakhs for a house with a real price of around 3.5 lakhs, we can say that the error is equal to difference of the two. So prediction and actual. Okay, so I have differential equal to 50,000. Now, as far as the price is concerned, is the 50,000 an error? Is a very big error in terms of a money transaction, but it may be a different way of interpretation in other model set. So for classification problem in the simplest setting, we can measure the error as 0 or a 1. A classification will give me a lot of trouble, 0 or 1. If I say 0 is equal to the person does not have a corona or a virus or fever or something like that, and 1 means it has, and if I predict wrongly 0 and wrongly 1, I will have a devastating model. So that is what we say. So if for example, a cat and dog recognizes, we can give an error of 1 if the model predict there is a cat, there has to be a dog. So for a picture prediction, the classification error is acceptable, but for a biological interpretation or for disease diagnosis or analysis, a model becoming 0 to 1 and 1 to 0 is not acceptable. So this is how our error has to be treated. So we decompose the error into some parts, and we decompose the error equal to real value and the predicted value. So whenever we are trying to decompose an error, we are trying to differentiate between the real value and a prediction value. So next time I am going to talk in detail about real value and prediction value. How do you deal with the real value? How do we deal with the prediction value? So thank you so much.